Okay, Lady Ada, what is this?
Hello and welcome to Show and Tell.
Yay.
Whee, yay. Hey, it's everybody. It's me, Lady Ada, with Mr. Lady Ada here at the Adafruit headquarters in downtown Manhattan, where we do all the electronics and design, kitting and manufacturing. But tonight we've got all these people who are visiting from around the world on their webcams here in this Google Hangout. And they're going to show off what they're working on, what they're making, crafting, and thinking up. And we have some Adafruit folks and some other folks.
And how much time do we have?
We have
a clock.
It's 19 minutes and 45 seconds. So we have 20 minutes. So people have an idea of how much pressure is. That's not per person. That's for everybody. So let's kick it off.
All right, we're gonna start with Scott, then Noe Pedro, then we'll go to Chris, and then we'll figure this out.
Okay, Scott.
Right. Hey, Scott.
You're first.
Hello. Thanks for having me. I thought I'd jump in and just talk about retro video games because that's kind of my deal right now.
Right.
I went down to Goodwill because I got this online. It's a Sega Genesis NOMAD, which I didn't actually know they made until I got into this whole thing. But basically, it's a Genesis that's portable. So there's a giant card slot here at the top where the actual Genesis games go. And, basically like every project I do, my goal is to get CircuitPython running on a cartridge in a handheld. I found that handhelds are great because even though the screens can be terrible, they're all self-contained, which is really nice. You don't have to worry about like, how am I going to plug this into my TV? And you don't have to worry about how you're going to power it because this actually has like 6 AA's or something that go in this like weird battery pack that's not in it, but it's on it. But it makes it really easy. So I think handhelds are kind of my jam right now. And I'm working on our secret handheld as well, but I won't show that.
Okay, so secret.
Yeah.
Mm-hmm.
All right. Well, thanks so much, Scott.
All right, Scott.
Thank you.
Noe Pedro.
Hey, what's up, guys? So it's sort of summertime here in the northern hemisphere, and we figured we'd do a couple different things. So there's sort of a trendy craze going on for educators and stuff. They're making slime. So DIY slime is a sort of a fun science experiment for the kids. Mm-hmm. So if you have any young ones and you want to do some fun DIY projects, check out the slime. Pedro, why don't you show them that slime?
Like a cool little galaxy one.
So we've been playing with different colors and things like that. And what we also want to do is we wanted a way to kind of store this stuff, maybe kind of create a kit so folks can take this to a workshop or so. So we took our AdaBox lunchbox. By the way, it's in stock still. If you haven't picked one up, you might want one. So inside, we were able to put a couple components in here. So if I open it up and turn it on, let me turn it on first. Hold on, if you can hold it up.
I would help, but I'm stuck in slime.
He's stuck in so you need help with it.
It's the problem with slime projects.
There's a lot of room that you can put in here. So we've got this little divider that we cut out of chipboard, and we have the Circuit Playground Express mounted up there with the battery pack. And there's actually a neopixel strip lined in the inside. So the idea is if you open the box, hopefully you can hear that, and you can see these lovely neopixels are lighting up, and you got a little animation up here. So we put this together with MakeCode, which is a really easy to use drag and drop code block based editor. And this just kind of makes a cool little fun interactive lunchbox. When I close it, it also does the sound and the lights turn off. Obviously you can't see that, but trust me, they are off.
Okay.
Through.
Ooh, yep.
So it's pretty fun. So if you guys want to put one together, check out learn.adafruit.com, and we got a video along with it. And hey, it keeps going.
Yeah, we'll show that tonight.
And don't forget to check out 3D Hangouts, where we talk about all the CAD design. There's still CAD design that went into this to create the device for that. So you can parametric, so you can edit that for your customized lunchbox. Yeah. And also we talked about some of the slime stuff, so check that out if you didn't see it today.
Slimetronics.
Okay.
Trademarked.
Everyone loves slime.
All right. JP. And then we'll go to Chris. JP.
All right. Hey, so I'm excited because we just published the guide for my little Cricket Carnival Bumper Bot, which is what I made on the live stream last week. So this is a little 2-wheel tank skid steering style bot. So we've got two motors, 2 wheels with these are called tail draggers. It has usually some sort of a caster back here. Some people use like a ball bearing or a deodorant stick that's been cut off. I'm using a paper clip, which actually works well because it's a lightweight cardboard bot. And I've also got a little servo on there that uses a flag to indicate forward and backward. I've got the Cricket, I've got the Circuit Playground Express. It's running make code. And when I fire it up, it will give us a little beep and turn on the neopixels. And now it's ready to drive. If I press the A button, it'll drive. If I press the B button, it'll stop. And if it collides with something, the accelerometer on Circuit Playground Express shakes enough to cause it to then do its avoidance maneuver, which is back up for half a second with both wheels going, stop one wheel, but continue another. So we do a little turn, and on its way, it can go avoiding stuff. So this is it in its little drive mode, driving along, stop. Now I'm going to shake it. And now it's just done its little backup thing, and then it starts driving forward again. So that is my fun little project that we've got a learn guide out for, so you can find out everything you need to know about building your own bumper bot. And I was excited because Lamore gave it the much cooler name, which is Cricket Carnival Bumper Bot.
The carnival theme.
It's good. So another quick thing, I will put in a little tease for my show tomorrow. Live stream is going to be at 1 o'clock Eastern time, and I'm going to be doing something with an eyeball.
I see what you did there.
Aye. Okay. Thanks, JP.
Thanks, guys.
All right. We're going to go to Christian. Christian, take it away.
Can you hear me?
Yep.
Okay, let me get the screen share going here. Wait up. Press Alt-Tab. Mouse click. Click minimize. Minimize window. Go to sleep. Here we go. Okay, this is a project that I hope I never use. And basically, it's a gadget that I would use only if I'm ever in the hospital again. Which, given my situation, I'll be there eventually, but hopefully not for a long time. This wire here is a gadget that the St. Vincent Hospital made me probably 30 years ago that plugs into their nurse comm system. And it's just a little lever switch on the end of a cable with a plug on the end of it. And here it is, as I used it a year and a half ago. I put a little 3D printed ring on it to help me hold it. The problem is, if I'm on a ventilator, I can't talk. The only way I can communicate is by typing on my iPhone or my iPad using a switch control with buttons like these. But I can't use the nurse call system and the typing, Bluetooth typing system at the same time. So I need a master gadget that will do both. And here's some CAD drawings. I start out with a 2.4-inch TFT display wing. And I showed this CAD drawings a couple of weeks ago, but you can see I've added a wire on there. And that was one of the reasons I modified Noe Pedro's designs, is I added attachment points so that you could actually model the wiring. This wire connects the backlight display to pin 12. Add on top of that an M0 BLE with some stocking headers. On top of that, you put a non-latching relay FeatherWing, which I had to model myself. You didn't have one of those. Or, yeah, I think, well, maybe you did, maybe you didn't. I don't remember. I updated it, whatever I did. Here's the signal wire connecting the pulse signal to pin 11. I need a way to plug the cable into the nurse call system. And so I thought, well, I'll just use a barrel jack. So I had to model the barrel jack. I need to connect 4 wires to my micro switches. So I thought I would use a TRRS 4-conductor cable. And this is the jack from Adafruit that I modeled. It's going to go into the box. By the way, I wrote you about the plugs not working very well, the ones that you sell. I've tried 2 other companies to order TRRS plugs, and they're all the same as yours.
No.
So I think that's just going to be a tough thing to solder to. I may update the whole thing later. I'm thinking about using a modular phone jack, like an RJ11, because it's got 4 conductors. It would be a nice, easy way to plug something in that way. But for now, I've got the TRRS working. Here's how it's all wired up in a 3D printed box. As you see, I've modeled all of the wires using Fusion 360 to get the wire layout just right. But again, that's one of the reasons I updated the FeatherWings, was to add little sketches that make it easy to attach routers. Here's with a LiPo battery and a slider switch, and I modeled in the battery wires as well. Here's a view of how the battery fits into the lid and how the switch is mounted. And here's the 3D printed case. I even embedded or embossed little on-off labels next to the switch. You can see the USB port on the left front corner and the other two jacks on the right side. I originally tried to make it a snap fit using some examples that Noe and Pedro did, but because of the sides of the box are rather thin and the seam is in the middle of the box instead of right at the lid, the sides are too flexible, and so it comes apart much too easily. So instead, I added some little tabs where I can stick some screws in it. Here's the assembled box showing the inside components as we put it all together. And here's another view from the outside with my little push buttons wired into it, USB wired into it. The display isn't necessary for calling the nurse or for using it on the, but if I also want to plug it into the laptop, I can use this display to use mouse controls. And so that's another alternative. And for more information on our projects, visit tech.cyberfive.com, and all of the Fusion 360 models that I showed today, except for my box, which is just custom for me. But all the parts are available on GitHub.
All right. Thank you so much, Chris. I'm going to name that thing for you. You'd rather have it, not need it, than need it and not have it box.
Yes. That's right.
I don't know what the acronym is, but it's fitting.
Yeah, I should have started working on it right after I got out of the hospital a year and a half ago, but I got involved in other things, and I think, hey, I really need to do this. Someday it's going to happen, and I want to be ready. So
good insurance policy.
Well, it looks really good.
Okay, next up, JMK. Hello, JMK. What you got going on this week?
So, this week or like maybe a week ago, I made a turntable originally for my YouTube channel, so I could have like at the intro of the video or something, like the introduction, the start of it, like whatever, like maybe if I'm showing off something, I have that thing rotating in a turntable. So I didn't want to buy one because they were kind of expensive, and I didn't really want to use my $20 on that. So I decided I have these little bits and a motor lying around, and this is just a box from some speaker. I just used all the things from that box and this cardboard piece to make it rotate. So what I've done is I have just a normal motor in variable mode. So if you look at the box,
oh, there you go. Nice.
At the bottom, how you can look at it is I've hot glued this all so tight it probably is waterproof by now. But this is the power bit. This is the control. So if it's at the middle, nothing. That way. It's in variable mode. If I switch it to one way, I can get more precise control of one direction. But so what I've done is, if you give me only like a second, hold on, then I'm gonna. Boop. I put the Adafruit logo on it.
That's right.
To show spinning. So I have my iPod Nano. I have my iPod Nano 6G out. My camp doesn't allow like a laptop or an iPod Touch or like a phone to bring to my camp. So me and my mom went on eBay and we bought an old iPod Nano. So I decided I'm gonna put the Adafruit logo on it. So here it is. I'm gonna quickly start spinning.
Okay, let's see it spin.
It's an excellent presentation.
This is great.
Spinning Adafruit.
Perfect. Well,
all right.
We can put a sticker on it?
Yeah, if you want, you can email us supported Adafruit and we'll send you a sticker.
Okay, thanks. Bye-bye.
Then you can have it spinning and also listen to your iPod.
That's right.
Yeah.
Okay, next up, Techniack.
All right, hey guys. So I just, oh, my internet will cooperate today, and I screen share. I actually taught myself Fusion 360 this week. I'm just watching through a whole bunch of your guys' videos. So this is a box of design for Magic the Gathering to house cards. It has an interior dimension that lets you hold about 60 cards. I think it's like 55 because my laser cutter won't accept DXF files, so you need to rescale everything. And then I made, actually, somebody ordered off of me a little business card stand. So this front part is acrylic. It's kind of hard to see in the appearance menu. But then everything else in the back here is just a couple different pieces of wood. And I'm going to have a tutorial coming out soon because I found there's not actually that many YouTube tutorials on how to design the tabs, the lock tabs. So
Looks great.
So I also actually have here, if I...
You could put a virtual sticker on that since you have...
Yeah, I will. But so we actually milled out one of the boxes. It actually looks really nice. And I designed it to use glue, but it's not actually using any glue because these back pieces printed too big. So you sand it until it fits, and it's just press fit together.
Nice.
Cool.
Yeah.
Good work.
All right, and thanks for the suggestion with the timer. We're running it this week, of course. We're running a little bit later, but it works. You can see you got 3 minutes and 37 seconds left.
All right. Yeah. Next.
All right. So everyone, use your time wisely. We're going to go to Joshua, and then Matt, and then Scott. All right, Joshua.
Hi,
take it
Joshua.
away.
Hello there. Can you guys hear me?
Yeah.
All right, cool. So here's my little project that I've done. I have a friend of mine who is blind, and I had put together a little device for her, though this is just the parts. It's actually going to be going into a compact. She likes makeup and fashion a lot, but unfortunately when she goes shopping, she can't see colors, so it has to get described to her. So I'm using a classic playground. I've got it battery powered. I've also got the text-to-speech device there, and also I have, I don't know if you can see everything there. This is the color sensor. Yep. And so what I do is I actually turn it on, and it should just boot up. And then everything that happens here, I don't know if you can hear it or not, that it has different modes. It has a select mode where it will select colors. And then after that, it goes into 2 other modes, which will give it the RGB values and the HSL values. And also there's a third mode called sparkle mode, which because she has RP, so what happens is that she can see light and darkness, but sparkles is something that she uses for brain stimulus. So she sometimes will push her heel into her high in order to get stimulus in her brain because she can't see. I have a little sparkle mode on there so you can see it. I'll demonstrate the program real quick here. I have a little red clipper here, and I'm going to just go over to the eyeball, and every time you select a different mode, it makes a different sound.
Yeah.
So you know which mode your color picker mode. So then it basically tells you the color name, and then if it's a light or dark shade of another type of primary color. So it knows about 400 colors that I have. I also have all the code up on GitHub if you guys want to take a peek at it or see what my color selection is. Yeah. So it'll tell you what the color is. It'll say, for example, like, red shade of dark red or light red. It also can identify if it's gray, black, white, brown, which is, non-spectrum colors as primary colors, plus 12 primary colors. And then you have the 400 kind of selections, which are like mint or, emergency orange or, flavorful color names, just so that you have a selection of them. Right now, this poor Classic is running, basically it's 91% full. I crammed it pretty full of stuff. And like I said, you can go to the next mode and it'll tell you it's RGB mode. Hopefully we'll hear it.
Shade of dark red. R equals 122. G equals 24. D equals 24.
And then it will actually do that for both HSL colors too. And then finally there's the sparkle mode, which, whoops. There we go. And there we go. And then that's the sparkle mode that, when she's bored, she can just open it up and take a look at it, and it'll just sparkle colors at her. I'm going to screen share a little quick because I'm actually trying to do the case for it, but I don't have a 3D printer available, so I'm just sort of putting it together as best I can. But if I screen share here, share that out, we should see, I believe you can see the Blender rendering here that I have of the actual case. And I'm still trying to put it together, but hopefully I can get someone to get that printed like at a UPS or something like that. But that's the project I'm working on.
Oh, so cool.
This is fantastic. Okay, you get a couple things. One, email support at Adafruit, and you get a as seen on show and tell sticker. We also have an AT maker badge, which I think this certainly works for. And if you could put in attention, Phil, they'll send me the note, and I'll post about this since you have the GitHub code up, and other people might be able to make and remake this as well.
Okay, attention, Phil, you said?
Yeah, that's me. Or PT.
Okay.
Yeah, and we'll do a blog post, and we'll also get you the sticker and the badge.
All right, and where do I send that email to then? Or
support at Adafruit.com.
Oh, support. Okay.
Yeah.
Attention, Phil.
And
right.
One other note, because you built this project, and this was for someone who needed some assistance for color. This is just good user interface, anyways. Like, this is just a better project, generally speaking. So fantastic work, Joshua.
Yeah, and like I said, as soon as I get it printed, hopefully I can get something completed for you.
Yeah. All right.
I love the sparkle mode. I like it's just like bonus. It's like toss it in.
All right, we're gonna go to Matt, and then we're gonna go to CScott. Matt, take it away.
Hey guys, I updated my airsoft project. I got a 3D printed case, external GPS antenna, laser rangefinder, and the old parts as well. I made 5 software modes. So if you see on the screen, it's backwards. It says mark clear. That means if I hit the button, it will mark my location as clear in a map. And then night mode just turns the LEDs off. Mark target uses the laser and the GPS to mark an enemy location in my map. And
wow.
And I have just a compass with the laser rangefinder underneath it. So it shows you how far it is.
Okay. I'm definitely not going to fight you in airsoft. You're going to win.
Yeah, here's the. Let me show you the map real quick. I did a test with it.
It reminds me of like the UFO footage where they show, they're just like, look, you can see this like UFO skirting away and through the crosshairs and stuff.
So I walked around and then I marked 6 targets and they all showed up in the map.
Oh, wow.
Nice work.
This is intense. This is like the best game of airsoft. All right, Matt. Excellent work.
Thanks.
All right. And of course, if you want a sticker, support at Adafruit.com and we'll send you out. All right, CScott, play us out.
Hey, guys. So a couple things here.
Your camera's off, unless you just want to be
the camera's off because I'm about to do a screen share.
Okay. But you look like talking fireworks, which is fine, too.
I'm going to share entire screen, but see if that works. There. But I was talking about working on an old machine again and making new voice boards. Well, Roland has this habit of using the hardest to find parts ever. So I'm not even going to try. Like this is a schematic of a Roland Jupiter 6 voice board, and what they did is they put 4 voice circuits on each one, but since it's a 6 voice, they left half of them off of one of the 2 boards. Well, right away we have a little problem here. This is an Intercell 14-bit DAC. Well, number one, Intercell raises a red flag because they haven't been around for 20 years. And 2, a 14-bit DAC from 1983 is pretty hard to get. So we're just going to use our favorite flavor of a nice 16-bit DAC here that has an SPI interface and whatnot to connect to. It was using an 8031, but this will be replaced with a CircuitPython Feather. And because there's nothing magical in here, it's receiving codes from a master CPU and then assigning voice parameters and gates and pitch voltages to the rest of the circuit. Now, the whole reason we're doing this is this little block here. It says VCFC attached VCF circuit diagram. Well, that's over here. This is a Roland custom chip called the IR3109. It was essentially 4 operational transconductance amplifiers in one package, but I don't like it, and I don't like the way they wired it, so out it goes. I'm going to replace this with something better. Similar topology. This is 2 state variable filters. You could switch low pass and high pass of the first one into low pass and high pass of the second one, but they used individual. This had a feedback loop and this had a feedback loop. That's not the way you're supposed to do it. So I'm going to fix all that. Anyway, where am I? Here we are. Back to Screen share back to me as soon as I click that button, and hopefully I show up here in a minute.
Hello.
Anyway, yeah, I forgot to mention something last week, that this is how engineering is supposed to work. I say, hey, could you add these pads and these signals to this board? And another engineer says, yeah, here. And they show me, say, here, how's this board look? Well, that's what you did with a feather. Thank you. This is how it's done. There's no
well, you also asked for the I2S M clock pin, and I exposed it. Even though I2S M clock doesn't work that great on this chip, I'm just warning you.
This is how it's done. I agree.
They're there.
This is how it's done. There's no middle management. There's no passing it to the front office. It's just like, put this in here, please. Here you go.
No sales engineer asking you if you're going to buy 1 billion of them.
And well, a sales engineer. Oh boy, I have so many stories for sales.
I know.
You know, a sales engineer's job is to basically promise the moon when at best you might get a fake moon rock.
Right.
So, you know, it's like I remember now 30 years ago, back when networking was a little bit tougher to do. You know, we had one salesman saying, "Oh yeah, we could do networking with this process control." I'm going, "Can't. There's like a serial port on this thing. It doesn't do TCP/IP or anything." But we put a little outboard circuit on there that would speak rudimentary TCP/IP and get parameters into and out of it, so that you could mainly it was to monitor several units in a factory setting. Control room would have a display of everything, and you didn't have to go out and look at, does this clarifier, what's the reading for this clarifier, what's the reading for this vacuum chamber, and so on. Anyway.
Keep sending good suggestions, and we'll keep doing it, but you do have to buy 1 million of them. Nah, just kidding.
Oh, yeah, well, yeah.
We're going to have the Feather M4 in a week or two, so you'll be able to pick them up.
Okay, you got anything else?
That is it. I just want to show you what I was going to be getting myself into with the Jupiter 6 board. You know,
yeah.
She has done a roll-in device before, and she should know quite well how big of a pain some of those parts were to get.
There's a reason I don't do that anymore.
Well, if there's one thing that I can impart in all of the work I've ever done on vintage synthesizers, it is don't bother using the same parts. Only the people who somehow are deluded into thinking that you have to have them for that sound are going to protest. But with a transistor circuit, you can fix anything with biasing. Okay, you can fix anything. You shift the bias, you get a different HFE component in there. You can get it to work. That's what I did with the Chrobiax. That's what I did with the Chromineus. That's what I'm going to do with the. I don't know how I'm going to put the word crow in the Jupiter 6, but I'll get there. Anyway.
Words of wisdom. All right. Well, thank you, everybody. We'll be doing Ask an Engineer in just 1 minute. Thank you, Techniack. Thank you, Scott. Thank you, Noe Pedro. Thank you, Matt. Thank you, Joshua. John. Thank you, JMK. Thank you, CScott. And thank you, Chris Young. We're here every single week, 7:30 p.m. Eastern Time. Show and tell. This was an epic one. Thank you so much, everybody.
All right. See you in 2 minutes.
Bye-bye.
1 minute.